Okay, today we're going to start talking about lesson 823. So we're still talking about complex numbers. Remember, that's just numbers that are in A plus BI form. It has a real and an imaginary part usually. And we're going to talk about equations, not so much today, but more so tomorrow. The very first question we're going to look at today is 8-97, and we're going to learn how to graph imaginary numbers. And I promise you this is probably the easiest thing we do all year. So the first one says 2 plus 5i. That's what we're going to be graphing. So where we normally have the x-axis, this is the real part. So that's where we're going to go to the right to. Okay, real positive is this way, real negative is that way. And the imaginary part is where the y-axis usually is, and positive is up and negative is down. So to graph 2 plus 5i, I'm just going to go right 2 and up 5. And this point right here represents 2 plus 5i. Okay, it's really that easy. Number 2 says 6 minus I. So I'm going to write that in red. And I'm going to graph it in red. So I'm going to go right 6 and I'm going to go down 1i. So that point right there represents 6 minus I. Okay, next one is negative 5 minus 3i. So I go left 5 and I go down 3. Negative 5 minus 3i. The next one says 4, like just 4. I'm going to use green again. So 4 has real parts and it doesn't have any imaginary parts at all. So I'm just going to do this, and that represents 4. Okay. The next one is 7i. So again, there's no right or left. It's only up to 7i. Okay, so that red is 7i. And then the very last one is negative 4 plus 2i. Okay, negative 4 plus 2i. So I'm going to start at what we think of as the origin. I'm going to go left 4 because it's negative on the real, and plus 2 because it's positive in the imaginary. Okay, so how do we graph complex numbers? We use a real and an imaginary axis. Real part is first, imaginary part is second. Okay. Number 99, we're going to talk about the absolute value of complex numbers. Now remember, absolute value means the distance from 0. So really, when I say, what's the absolute value of 9, you should be thinking of a number line and saying, well, how far apart is 9 from 0? Well, it's 9. How far apart, that means the absolute value of 9 is 9. Okay. If I say what's the absolute value of negative 9, again, I'm just asking what is the distance from 0. The distance from negative 9 to 0 is 9. That's why the absolute value of negative 9 is 9. Okay, so we're going to keep that in mind. Distance from 0. And we just talked about how to graph on the real and imaginary. So if I have negative 8 plus 6i, I'm going to go left 8 and up 6. Okay, I went left 8 and up 6. Now, because I'm talking about distances, even though I went left 8, I don't really care that it's negative. Okay, I did go up 6, and again, absolute value means distance from 0. So all I'm going to do is find the distance from 0 to that point. Okay, remembering from geometry, that's just the Pythagorean theorem. So 6 squared plus 8 squared equals x squared. You guys know how to do this. You are going to get an answer of 10. Okay, 7 minus 2i, I go right 7, down 2, and again, because it's a distance thing, I don't even need to put that it's negative 2, I just am going a distance of 2. So 2 squared plus 7 squared equals blue x squared. That's 49 plus 4, that's 53. So it's exactly the square root of 53. If you want to plug that into your calculator and find what it is approximately, you can. And remember, technically speaking, when I take the square root of something squared, I would need to put plus or minus the square root of 53. I should put plus or minus 10. However, because these are both talking about distances, only positive values make sense. Okay, so I can disregard the negative part. Last one. 4 plus I, I'm going to get rid of the 7. If I go to the right 4 and I go up 1, I have a little triangle. Okay. And again, all I'm doing is Pythagorean theorem. Or if you're figuring out this pattern, all you're doing is taking the absolute value of -8 and the absolute value of 6 and putting that into Pythagorean theorem. So 7 squared plus 2 squared equals c squared. 4 squared plus 1 squared equals c squared, or x squared. Okay, so that's going to be 17 equals x squared. So the absolute value of 4 plus I is going to be the square root of 17. Okay, so graphing, pretty darn easy. Finding the absolute value is just understanding how you graph it and then drawing in your right triangle and finding the missing hypotenuse. Last thing today is definitely related to complex numbers, and it's going to feel very different than the last two examples. Okay, this is asking how many roots. And when you look at this graph, you should see, although it's a really rough sketch by me, it is a parabola. It's going down and then up. So down and up tells me it's x squared, and I'm looking for 2 roots. And of course, because I can see it crosses twice, this graph has 2 real roots. Okay, anytime it crosses the x-axis, it's real. If I take this same graph and shift it up, okay, it's still a parabola. I'm still going down and then up. Okay, each down counts as 1, each up counts as 1. That would be x squared. That means there are 2 roots here. However, because it never touches the x-axis, these are 2 complex roots. You could call them complex, you could call them imaginary, you could call them complex, imaginary, or non-real. 2 real roots. Okay? Over here, it goes down 1, up 2, down 3. So there's a down, up, down. 1, 2, 3. That means there are 3 roots. And if you look, you can easily see that this graph crosses the x-axis 1, 2, 3 times. So that has 3 real roots. Okay? Now, this graph is still down, up, down. 1, 2, 3. So if I'm just tracing it, I'm going down, and I turn around and go up, I turn around and go down. Okay? That's an x cubed. It still has 3 roots. However, it only crosses the x-axis 1 time. So it only has 1 real root, but remember we said it has a total of 3. So this down, up that never hits the x-axis, that accounts for 2 complex roots. For a total, okay, this graph has a total of 3 roots. Okay, down, up, down, 3 roots. 1 is real and 2 are complex. Remember, complex roots or imaginary numbers always come in pairs. That's that plus or minus the square root of a negative number that always comes in pairs. Okay, that's it for today.